You know, we're always talking about making AI smarter, but what if we could make it wiser? What if we could turn a single AI into an entire team? Well, get this. A brand new research paper just dropped that shows us how to do exactly that. We're talking about AI agents that are smarter, faster, and way more efficient.
All right, so let's just start with this idea. Imagine for a second, what if a single AI could act like an entire team of experts? You know, like having a researcher, a planner, a coder, and a fact-checker all rolled into one, all working together inside one brain to crack a really tough problem.
Well, that's not science fiction anymore. This new research shows it's actually possible. We are literally talking about a new way for an LLM to simulate that kind of teamwork internally. So how on earth did they pull this off? And, why is this such a game changer?
Okay, so before we get to the breakthrough, you gotta understand the problem they were trying to solve. For a long time now, AI has been caught between a rock and a hard place when it comes to dealing with really complex, multi-step jobs.
It's kind of like this. You've got a tough project. Do you hire one super smart person, or do you put together a massive committee? The thing is, both of those options have some pretty big problems.
So on one side, you've got the lone worker. That's like a single AI agent. Yeah, it's fast, it's efficient, but throw a really complex task at it and it just gets overwhelmed. Then you have the clumsy committee, a whole team of different specialized AIs. Super powerful for sure, but man, is it slow and expensive. And getting them all to talk to each other, it's a total nightmare.
So yeah, the old way, something called tool-integrated reasoning, or TIR, was this very rigid process. It was just think, then act, think, then act. Super one track. But this new method, it's all about dynamic collaboration. It's not a one-way street anymore. It's more like a creative brainstorm, with all these different roles being played inside one single model.
And that is where the hero of our story comes in. The solution that might just fix this whole teamwork mess for good. It's called Chain of Agents.
Okay, so what is Chain of Agents? Let's break it down. COA for short is basically a whole new way for these models to think. It lets one single model simulate an entire team of specialized agents internally, so you get all the power of that big committee but with the speed and efficiency of that lone worker. It's literally the best of both worlds.
And check this out. This table from the paper really says it all. Look at the other methods. React, multi-agent systems, TIR, they all have a weak spot. They're missing something crucial. One can't collaborate, another can't learn end-to-end. But Chain of Agents? It's the first one to come along and just tick every single box. Tool integration, end-to-end execution, collaboration, data optimization, the whole shebang.
All right, this all sounds incredible, but how? How do you actually teach one AI to think like an entire team? What's the secret?
Well, it turns out it's this really clever two-step process. I like to think of it like how you'd train a pro athlete. First, they watch tons of game film to learn from the best, right? Then, they hit the practice field with a coach to actually hone those skills.
So step one is something called multi-agent distillation. This is the watching the tapes part. The researchers basically let their new model observe these big, clunky, but powerful multi-agent systems solve problems. The model watches everything, analyzes every successful move, and then it distills all those winning strategies down into its own, much leaner thought process.
Then comes step 2, agentic reinforcement learning. And this is the coaching session. The model takes everything it learned from watching the tapes and starts practicing on new problems. Every time it gets something right, boom, it gets a reward. If it messes up, it learns, adjusts, and tries again. It's this constant feedback loop that makes it super sharp and really perfects those new teamwork skills.
So that's the training regimen. It sounds great in theory, but the real question is, does it actually work? Let's get to the results, because this is where things get really interesting.
So the researchers use this chain of agents method to train what they call agent foundation models, or AFMs for short. Then they put them to the test against the best in the business on some of the toughest AI benchmarks out there.
First up was the Gaia benchmark. This one tests the AI on really tricky real-world questions. And look at that. The new AFM model just pulls ahead of the previous record holder. Not by a ton, but it sets a new state-of-the-art. A really solid start.
But hold on, it gets way better. Look at these next two benchmarks, BrowseComp and HLE. These are super hard. They involve complex web navigation and solving academic problems. And here, the difference is just staggering. AFM doesn't just win, it absolutely crushes the competition. We're talking 3 to 4 times better on browse comp. This isn't just a small step up, it's a giant leap.
And just to prove it's not a one-trick pony, they threw complex math problems at it using the AMY 25 benchmark. And would you look at that? Same story. A huge jump in performance, more than 10 points higher than the next best. This really shows that this chain of agents idea is powerful, no matter what domain you apply it to.
Okay, all those performance numbers are impressive. But this is the real showstopper. The stat that made my jaw drop. The AFM model isn't just smarter, it is insanely cheaper to run. We're talking a reduction in computational cost, basically how much power it needs, by almost 85% compared to those old multi-agent systems. That's like getting the performance of a supercar for the price of a bicycle. It's a total game changer.
So, what does all this add up to? Why should you care that we have a smarter, cheaper, more collaborative AI? Let's zoom out for a second and think about the big picture.
I mean, the implications here are massive. First, we're talking about AI agents that are way more powerful, but also way more accessible, right? Because they're so much cheaper to run. This could unlock using AI to solve really complex, real-world problems in things like scientific research or coding. It's basically a whole new blueprint for building the next generation of AI assistants. And maybe the coolest part, because they learn end-to-end, they're just going to keep getting better and better with more data.
And that really leaves us with one big, exciting question to chew on. We've just witnessed the creation of an AI that can literally think like a super team. So what's next? What are the truly hard problems, the grand challenges that these new AI super teams are going to solve for all of us?